Good morning, class. Here's practice test number 5, module 5, covering chapters 10 and 11. Here's chapter 10, analytic geometry, chapter 11, sequences and series. And here's the pledge. Before starting any exam, we pledge to receive basically no help from anywhere. Here's chapter 10, analytic geometry, the first part. And first, let's look at the concept. Identify and describe the conic sections. Conic sections are geometric figures formed by the intersection of a plane with a double cone. The types of conic sections include, number one, it's a circle. When the plane intersects one of the cones perpendicular to its axis, the resulting shape is a circle. As we look at this, the way we cut that, this is perpendicular to the axis, resulting in a circle. Ellipse, when the plane intersects one of the cones at an angle not perpendicular to its axis, as you can see from here. Parabola, if the plane is parallel to one of the sides of the cone, the intersection is a parabola, like this one. Hyperbola, when the plane intersects both naps, sides of the cone parallel to its axis, the resulting shape is a hyperbola, as it is the case here. So that's how we get to those shapes. These shapes have various properties and applications in mathematics, physics, engineering, and other fields. Again, that's a double cone. Rotating a line segment around an axis at their point of intersection generates two cones. That's how to generate a cone to begin with. That shares a common vertex, resulting in a double cone shape. So that's the synopsis of how we get those shapes. Now, let's start with a circle. So find an equation of a circle with its center at 1, -2 and radius 2. Graph the circle. Well, what is a circle? As far as the definition goes, we know how to come up with a circle. Definition. A circle is the set of points in a plane that are the same distance, called the radius, from a fixed point called the center. So if it's centered at 0, 0, x squared plus y squared equals r squared, it simply follows Pythagorean theorem, a squared plus b squared equals c squared. If it's centered at h comma k, x minus h quantity squared plus y minus k quantity squared equals r squared. It's very straightforward. It comes from the Pythagorean theorem, and this obviously the same thing, and the distance formula. Having said that, so a circle has this formula. If a center has h and k is that this formula. We know the area is pi r squared, circumference is 2 pi r. So in this case, we know the radius, we know the center. So here's 0, 0. So we are going to go 1 unit to the right, 2 units down. And we are going to write this as x minus 1 quantity squared plus y minus 2 plus 2 quantity squared equals 4. So that's the equation. Now we start graphing by putting the center. Now, how do you graph it? One easy way is to go back to the center. 2 units to the right and left gives you 2 points to the right and left of the center. 2 units up and down. So if we start with right and left, so the x coordinate, subtract r, which is 2, and you get -1, -2. And to the right, add r, that means 1 plus 2, you get 3, -2. Those are the 2 points. Go back to the center, up and down by r units. When we go up, that means we add 2 to the y coordinate, we get 1, 0. Down, we subtract from it, we get 1 minus 4. We put them together, that's the graph we're done. So that's Very straightforward concept. We are going to move on, everybody. All right, so let's see what happens here. Write the equation of a circle in standard form. Identify the center and the radius, graph the circle. So what do we need to do? It's very straightforward. We are going to use completing this square, which means we are going to put negative 4x next to x squared, positive 10y next to y squared. We're going to move the negative 7 to the right and make it positive 7. So that's the first step. Now, for each case, right here, I'm going to write it here and I'm going to erase it. B is negative 4 divided by 2 is negative 2. Square it, and you get 4. So we need 4 here. This one, B is 10 divided by 2, 5. Square it, 25. So we need 25, which means this is x minus 2 squared plus y plus 5 squared. Always put the b over 2. And 7 plus 4 plus 25 adds up to 36. So we have a circle centered at 2 comma negative 5. The radius is square root of 36, or simply 6. So that's pretty straightforward, everybody. We start with the center. Here, 0, 0, everybody. So we go 2 units to the right, 5 units down, and that's the center. Now, from the center, we want to go r units to the left and right, up and down. If I want to go left and right, so 2 minus 6 becomes negative 4 comma negative 5. 2 plus 6 becomes 8 comma negative 5, going up and down. So 2, if I go down, minus 5 minus 6 is minus 11. Up, minus 5 plus 6 is 1. So 2, 1. So we have those 2 points. And then we have the other 2 points. Put them together. Here's your graph. So that's pretty straightforward, everybody. Graph the ellipse by finding its center and vertices. X squared over 25 plus y squared over 16 equals 1. So let's discuss an ellipse as far as the equation and the graph is concerned. So here's the shape. It's elongated along the x or the y-axis, in this case, along the x-axis. This is centered at 0, 0. And it has a couple of x-intercepts at a comma 0, negative a comma 0, a couple of y-intercepts at 0, b 0, minus b. And if you pick any pair, P has coordinates x comma y. Let's see what happens as we connect it to these 2 points. And what are those 2 points? An ellipse is a set of points in a plane, the sum of whose distances from 2 fixed points is a constant. The 2 fixed points are called the foci. Each is a focus. So F1 and F2. Each is a focus of the ellipse. F1 and F2 represent the 2 foci of an ellipse. Now, PF1 plus PF2 is a fixed value, and it's equal to 2a. Why is that equal to 2a? Bear in mind, this distance is a, everybody. This is A. And if you look at AF1 plus AF2, AF1 is this distance. AF2 is this distance, which is the same as this distance. We're going to call it A1. So it's the same as A1, F1. And when you add those two, you get AA1. So this, I'm going to erase the whole entire thing again. This is the distance between the x-intercepts. Let's call this A1. And as you know, that's equal to 2 times k. So that's a proof, believe it or not. Also, if we call this point B and connect it to F1 and F2, of course, by symmetry, we see BF1 and BF2 are identical. And if their sum, according to this formula, is constant, and that constant is 2a, that means this distance or this distance must be a. This distance, of course, is a, and the distance from the center to each focus is called C. So we have this one is A, this one is B, this one is C. And it gives rise to Pythagorean theorem. As you can see, in this case, A squared plus B squared equals C squared in general. And C is the hypotenuse normally, but this is not the case here. The side, one of them is C, one of them is B, the hypotenuse is A. Therefore, first and foremost, the equation for an ellipse centered at 0, 0 is x squared over a squared plus y squared over b squared equals 1. If it's centered at h and k, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Now, a equals pi ab. I'm going to go over that in a moment, but I want to discuss this one. This is from Pythagorean theorem, okay? And in general, what do you put here, the one that is the largest? This is elongated along the x-axis. A is the largest. But if it's elongated along the y-axis, then B is the largest, okay? And note, a circle is a special case of an ellipse where A equals B equals R. Remember, for a circle, A equals pi R squared. And a circle is a special case where A equals B equals R. So instead of that, we can say A times B, and it gives rise to this equation. And we can further prove it in calculus. So that's the synopsis of what's an ellipse. So let me erase my work so we can look at the graph. So we are dealing with this equation. The center is at 0, 0. A is 5, B is 4, because the square root of 25 is 5. Remember, this is A squared. And the square root of 16 is 4. So we start with the center, which is 0, 0. And of course, we go A units to the right, A units to the left. Those are the x-intercepts. We go B units up, B units down from the center. And the graph is close to a circle because A and B are fairly close. But nevertheless, it's elongated along the x-axis. Identify the coordinates of the center of the vertices, the co-vertices, and foci. Graph the ellipse. And bear in mind, the elongated side gives you the vertices. So having said that, first and foremost, we are going to use this formula. So I'm going to write that. So we can clearly see the center is located at -5, +7. A is 2, B is 3. Again, square root of 4 is 2, square root of 9 is 3. So we're going to start with the center. So here's 0, 0, everybody. We are going to go 5 units to the left, 7 units up, and we get the center. Now, in order to find the vertices, because B is larger, we are going to go B units up and down from the center. So if I want to go down, I'm going to subtract 3. Okay, we're dealing with the B. So I get -5, 4. If I want to go up, -5, 10. And those are the two vertices. What about co-vertices? Go back to the center and go A units to the right and left. So going back to the center, A is 2. If I want to go to the left, is -7, 7. If I want to go to the right, -5 and 2 is -3, -3, comma 7. And those are the two pairs. Now putting them together, you have the graph. And as far as vertices and co-vertices, I want to again make sure everybody understands vertices along the elongated side. Okay. Now we want to find the foci. To find the foci, we are going to understand that this is a relationship which comes from Pythagorean theorem. And this is the largest side. This is the hypotenuse. So we either use a squared plus c squared equals b squared, or b squared plus c squared equals a squared. And in this case, which one do we use? B is the largest, everybody. Therefore, we are going to use a squared plus c squared equals b squared. C squared is 5, c is square root of 5. Therefore, we go back to the center, okay, back to the center, and because the vertices are up and down, we're going to go up and down. From the center, we're going to go up by square root of 5 and down by square root of 5, okay? So if we go down, the x coordinate doesn't change, 7 minus square root of 5, and about 4.77 for the sake of location, okay? And going back here, now up by square root of 5, that means -5 comma 7 plus square root of 5, which is about 9.24. And we locate those two pairs, and those are the vertices, the foci, everybody. And again, precise location and approximation, okay, everybody? So you need to understand why we use either one. All right, so what happens here, we are given the graph, so use the graph to determine the equation in standard form. Okay. First and foremost, we notice the center is not at 0, 0, so we're going to use this formula, x minus h quantity squared plus y minus k quantity squared over a squared, y minus k squared over b squared equals 1. So here's the center, and x is -2, y is +2. So first, location of the center is important. Now, these 4 important points, those are the vertices located at -2, comma 5, -2, comma -1, and those are the co-vertices located at, this is 0, 2, this is -4, 2. So this is the B unit, this is the A unit, and this is clearly larger. So A is just 2, B is 3. Everybody can see. And one easy way to evaluate this, everybody, you can look at, for example, this point and say they have identical x coordinates 5 minus 2b is 3. And you look at these 2 points, okay, or these 2 points, doesn't matter. You want this distance or this distance, and the distance along the x is 2. So it's very easy to see. So having said that, let's go back to this equation, x minus h. That means x minus minus 2x plus 2 quantity squared over a squared over 4 plus y minus k, y minus 2 quantity squared over b squared over 9 equals 1. So that's pretty straightforward, everybody. Given the equation of the asymptotes and graph the hyperbolas, there are 2 of them. A, x squared over 16 minus y squared over 25 equals 1. B, y squared over 25 minus x squared over 16 equals 1. So what's a hyperbola? Let's discuss that and the properties. We know how to come up with that. It was discussed in the beginning. A hyperbola is a set of points in a plane. The difference of whose distances from two fixed points called the foci is a constant. Pf1 minus Pf2 is a constant, and it happened to be 2a. The proof is easy. We will discuss the proof as we look at the graph here. So I want to make sure everybody understands how the graph thing works here. So we have a set of axes. We have these 2 blue parts or the graph, and this is a point, any point you pick with we call it P with coordinates x and y, and if we connect them to F1 and F2 are called the focus 1 and focus 2. So their distance PF1, obviously PF1 is larger, minus PF2 is 2a. I want to discuss that, and notice that if this works, if this is the case, never mind 2a, we want to come up with the proof by looking at this one. If this works for any point you pick, so it works for this point A as well. So AF1 minus AF2. What is AF1 minus AF2? Please understand, by symmetry, this distance, okay, is the same as this distance. So if I want AF1 minus AF2, it's the same as AF1 minus, let's call this A1, A1F1. And that gives you A1, which means this distance. And this has coordinates A, comma 0. So this is A, so this is 2A. So I hope you see why we arrive at 2A. Furthermore, vertices. The vertices are the points where the graph crosses the x or y axis. In this case, the vertices are on the x-axis or the x-intercepts. If it opens up and down, would be on the y-axis. Center. The point halfway between two vertices, the center of the hyperbola. It happened to be at 0, 0. Transverse axis. The line through the vertices is called the transverse axis. So this one. So there's some terminologies, and I'm going to erase my work so we can continue on that thoughts. And also this one, this is called fundamental rectangle. This L belongs here. Okay, so that's pretty straightforward as far as understanding the concept. And we are going to move on to work on this set of questions. So having said that, what do we want to write? We want to write the formula in general. So the formula is, and I'm going to x squared over a squared minus y squared over b squared equals 1. I hope you see, look at this one, similar to an ellipse. Instead of plus, we have a minus sign. Now, if the coefficient of x squared is positive, okay, that comes first. If y squared is positive, we're going to write y squared over b squared minus x squared over a squared equals 1. I want you to pay attention to the way I write this. I keep the a squared under x squared in both cases. When I do that, the equation of asymptotes will remain unchanged. Y is plus minus b over a times x. In some texts, they change that. Then this will change for this one. But I like to keep it this way, and the asymptote remains unchanged. Now, the Pythagorean theorem works out here also. Please understand that this distance is a, this distance is a, this distance is b. Now, the distance from the center to F2 or F1 doesn't matter. This distance is C. This distance is C, and that works out that C is always larger than A and B, and it follows Pythagorean theorem, A squared plus B squared equals C squared, everybody. So having said that, in both cases, the center is 0, 0. In both cases, A is square root of 16 or 4, and B is square root of 25 or 5 in both cases. So we have the center at 0, 0. Now, in both cases, asymptote y is plus minus b over a times x, so plus minus 5 over 4 times x. And we can draw the two lines. One of them is y equals 5 over 4 times x. One of them is minus 5, y equals minus 5 over 4 times x. So I'm assuming no one has any problem with those. Okay. Also, notice the fundamental rectangle. What I want to add here is this, everybody. See what color I want to use here. If you look at this one, okay, if it's done properly, the coordinates are 4 and 5. Okay, so basically A, comma B. And this one, 4, comma, negative 5. This one is negative 4, comma 5. And this one, negative 4, comma, negative 5. Please understand what happens here. If you have A, B, and you put those 4 points, it gives you the rectangle. The diagonals are giving you the two lines. So that's another way to find the two lines, everybody. Okay, so the vertices are, if we go back to this one now, never mind this one. This one, the vertices are at 4, 0, minus 4, 0. Those are the points, and you graph it and you're done. Done. What about this one? Now the vertices for this one, because y squared has a positive value, is at top and down. That means at up and down, that means the y-intercept. That means 0, 5, and 0, negative 5. Those are the two pairs, and those are the graphs. So I hope everybody understands what's going on here. So that's pretty straightforward, everybody. We are going to move on. Identify the coordinates of the center, the vertices, foci, and the equation of the asymptotes. Graph the hyperbola. Okay, so first and foremost, we are going to compare it to this one. So it's centered at 1, 2. A is square root of 9, which is 3. B is square root of 16, which is 4. And again, please understand that this is going to, because the coefficient of x squared is positive, it's going to open sideways. So the center is as 1, 2. So we go from 0, 0, we go 1 to the right, 2 up. And so we have that. Now, as far as asymptotes are concerned, the easy way to write that, again, I'm reminding you that for the center at 0, 0, we have plus minus b over 8 times x. So look at this one. The y changes to y minus k, the x changes to x minus h. So the y changes to y minus 2, and the x changes to x minus 1. That's how we get those formulas. So if we take the negative 2 to the other side, becomes positive 2. And if there are two of them. So I'm going to go with positive 4/3. First, I'm going to look at 4/3 only. So I have 4/3 x minus 4/3 plus 2. We put these two together and we get 4/3 plus 2/3 because 2 is 6/3 there, everybody. So obviously, this is the y-intercept. That means 0, 2/3. So 0, 2/3. If you set y equal to 0, that means 4/3 x plus 2/3 equal to 0. X becomes negative 1/2. And there you have it. So you could locate 0, 2/3 somewhere here, negative 1/2, 0 somewhere here, and you have your asymptote 1 of it. As far as the second one, and I'm going to rewrite the second one as well by erasing this. Now, the second one, y is minus 4/3 times x minus 1 plus 2, which is minus 4/3 x plus 4/3 plus 2. They add up to 10/3 because 2 is 6/3. And so obviously, this is the y-intercept, 0, 10/3. Now, if you set y equal to 0, 0 was minus 4/3 x plus 10/3. Obviously, minus 4x becomes plus 4x equals 10. Drop the 3, and x becomes 5/2. So we have those. That means 10/3 is 3 and 1/3. So a little bit above 3. 5/2 means 2.5, somewhere there. And that's your second asymptote. It's very straightforward, everybody. So I'm going to erase my work because I need this space. All right. And so we know it opens sideways, and we are going to start from the center, okay? And because A is 3, we are going to go A units to the right and left of the center. And to do so, if I want to go to the right, that becomes 4, 2. If I want to go to the left, 1 minus 3, I need negative 2, 2. So I plot those two pairs. Here's my graph, and I'm done with the graph. Now, the next thing that I want to come up with is the value of the C, because I'm interested in finding the foci, and always A squared plus B squared equals C squared, because C is always larger than A and B. So 9, B3 squared is 9, 4 squared is 16, so we get 25. C squared is 25, C is 5, okay. And starting with the center at 1, 2, and finding C equals 5, we're going to go C units to the right and left. That means if I want to go to the right, I'm going to add 5, I get 6, 2. If I want to go to left, I'm going to subtract 1 minus 5 is negative 4, comma 2. So we're going to locate those. Those are the foci. So focus 1, focus 2, and here's the fundamental rectangle. They didn't ask for it, but in case. Okay, it's pretty straightforward, everybody. By the way, it's not going to be 3, 4 as we did that over there because the center is at 1, 2. Okay, so just for the sake of argument, if this is 1, you got to add to this, you get 4. This one, you get 6. So this point, for example, let me see what color I need here. This point would be, okay, 3 plus 1, and then 4 plus 2. As you can see, it has coordinates 4 and 6. It may be hard to see here, but you get the picture. All right. We want to use the graph of the hyperbola to determine its equation in standard form, and again, reminding you of that. So having said that, let's see what we need to do. The center is at negative 1, 0. The vertices are at negative 1, negative 3, and negative 1, positive 3. So let's write the center. And we want to find A and B. So we're going to write the vertices. So these are the 2 points. And it opens up and down. So it's going to be from the center, B units up, B units down. And so what is B is this distance, which is 3. I hope you see that they have the same X coordinates. The Y coordinate goes from 0 to 3. So B must be 3. The distance of 3 is very straightforward. The foci are C units up and down. As you can see again, we have the same X coordinates. Okay, so take a look. And this distance now is just 3 square root of 2 minus 0. So if this distance is 3 square root of 2, then we can write the foci is located at negative 1, 3 square root of 2 minus 1 square root of 3, 2, as you can clearly see that. And so that distance gives us C equals 3 square root of 2. A squared plus B squared equals C squared. Remember, always this is the case. So A squared plus B is 3 squared, and this is 3 squared of 2 squared. This is 9. This is 9 times 2, 18. I hope nobody has any problem with that, which means A squared is 9. A is 3. And so we're going to go with the general formula. And the general formula is this one because it opens up and down, everybody. So we are going to write the center, okay, y minus k, so y minus 0, so that means y squared over b. A and b happen to be the same, so y squared over 9 minus x minus h, x minus minus 1, that means x plus 1 quantity squared over, again, 9 equals 1. And we're going to use the formula y minus k is plus minus b over a times x minus h for the sake of finding the asymptotes. You don't have to, they didn't ask, but just to remind you, we are y, there's nothing next to it, so y minus 0 in essence equals plus minus b over a, 3 over 3, x plus 1, and simply put this is 1. So there are two asymptotes. One of them is y equals x plus 1. One of them is y equals minus x minus 1. So very straightforward, everybody. Okay. Here's the two asymptotes. And if you were to graph the fundamental rectangle, looks like